The Prism Refraction Simulation is an interactive educational tool designed to help students explore the principles of refraction, specifically how light bends as it passes through a prism. By providing a hands-on approach to investigating the behavior of light as it interacts with a transparent triangular object, the simulation offers a comprehensive learning experience that covers key concepts in optics. The simulation allows students to drag a torch to different locations, observe how the prism changes the path of the light ray, and explore the separation of white light into a spectrum of colors. Refraction is the bending of light as it passes from one transparent medium to another. The Prism Refraction Simulation begins by introducing the concept of refraction, explaining how the difference in density between two mediums affects the speed and direction of light. When light enters a denser medium, it slows down and changes direction, a phenomenon known as refraction. The simulation provides an interactive platform where students can actively engage with the concept of refraction. By dragging a torch to different locations and observing how the prism changes the path of the light ray, students can gain a deeper understanding of the principles governing the behavior of light in different mediums. This hands-on approach helps students grasp the complex and fascinating world of optics. The Prism Refraction Simulation features a transparent triangular object with three refracting surfaces at acute angles with each other. This prism is designed to separate white light into a spectrum of colors, a phenomenon known as dispersion. By exploring the behavior of light as it passes through the prism, students can understand how the prism's geometry and the difference in density between air and glass affect the path of the light ray. The simulation allows students to drag the torch to different locations to see how the prism changes the path of the light ray. By moving the torch, students can observe how the angle of incidence affects the angle of refraction and the resulting dispersion of light. This interactive feature helps students understand the relationship between the angle of incidence, the angle of refraction, and the separation of white light into its constituent colors. The Prism Refraction Simulation helps students explore the bending of light as it passes from one transparent medium to another. Due to the difference in density between air and glass, the speed of light changes as it enters the prism, causing it to change direction. By observing the path of the light ray as it passes through the prism, students can see how the change in speed and direction results in the separation of white light into a spectrum of colors. The simulation allows students to observe the dispersion of light as it passes through the prism. White light is composed of a spectrum of colors, each with a different wavelength. As the light enters the prism, each color is refracted at a slightly different angle due to its unique wavelength. This results in the separation of white light into its constituent colors, creating a visible spectrum. By exploring the dispersion of light, students can gain insights into the principles of refraction and the behavior of light in different mediums. The simulation provides an interactive platform where students can actively engage with the concept of refraction. By dragging the torch to different locations and observing how the prism changes the path of the light ray, students can gain a deeper understanding of the principles governing the behavior of light in different mediums. The visual nature of the simulation makes abstract concepts more tangible. Students can observe the bending of light, the separation of white light into a spectrum of colors, and the relationship between the angle of incidence and the angle of refraction in real time, helping them to grasp complex ideas more easily. The simulation offers immediate feedback, allowing students to see the results of their adjustments instantly. This helps correct misunderstandings quickly and reinforces learning through trial and error. The simulation covers a wide range of topics related to refraction, including the concept of refraction, the behavior of light in different mediums, the geometry of the prism, the bending of light, and the dispersion of light. This comprehensive approach helps students gain a holistic understanding of the principles of optics and their applications in various fields. The Prism Refraction Simulation is a valuable tool for teaching and learning about the principles of refraction and the behavior of light as it passes through a prism. By providing an interactive, visual, and comprehensive platform, it helps students understand the bending of light, the separation of white light into a spectrum of colors, and the relationship between the angle of incidence and the angle of refraction. The simulation allows students to drag a torch to different locations, observe how the prism changes the path of the light ray, and explore the principles of refraction and dispersion. Whether used in a classroom setting or for individual study, this simulation can significantly enhance the learning experience and build a strong foundation in optics. Through exploration and experimentation, students can gain a deeper appreciation for the complex and fascinating world of refraction and its applications in various scientific and engineering fields.